Alright, next what we're going to talk about is relative maxima and relative minima. And what this means, if you look at the graph right here, what a relative maxima and a relative minima is basically where the point crests, or where there's kind of a valley. That doesn't mean that it's the maximum value of our graph, because as you can see with our arrows, this graph has continued to go down and down and down, and this side will continue to go up, up, up. So anyway, our relative maxima is basically where you have a turn in your graph. So where it goes from increasing to decreasing, or decreasing to increasing. So what we're going to do is, there are a couple ways to say this. The relative maxima at. So what that's asking for is asking us for the x value. So as you can see, our relative maximum value is going to be at x is equal to -4. And it's going to say the relative maxima is. And when they ask for that, they are looking for the function value. And we know f of x is equal to y. So therefore, the y value here is going to be 2. So it could ask you different things. It could say the relative maximum is at what point, and you would give the x coordinate, and then the relative maxima is, and that's the y coordinate. Same thing, we're talking about relative minima. Okay, it's the lowest point on your graph relative to any other point around it. So your relative minima is going to be the x value at the x value of 1. So this is where it occurs, and the relative minima is, that's going to be asking for the y value. So what is the relative minimum value? And you can see it's -5. So relative and maxima and relative minima, you can look at. Again, it's going to be where it changes from increasing, decreasing, or decreasing to increasing. And all the other points around it for relative maxima will be less than that. All the other points around it will be a relative minima, will be more than that point around it. It's going to ask you where it occurs and also what it is. So keep that in mind.